The effortless turn that would revolutionize driving forever glided through the steering wheel of the experimental Chrysler Imperial on June 15, 1951. Francis Davis, the brilliant hydraulic engineer who had spent decades perfecting the system, watched as elderly test drivers and petite women operated the massive luxury car with fingertip control that seemed impossible with conventional steering systems. "Gentlemen, we've just eliminated the automobile's greatest physical barrier," announced Chrysler's chief engineer as the prototype Imperial demonstrated steering control that required 80% less effort than conventional systems. For the first time in automotive history, driving a car doesn't require the physical strength of a construction worker. Anyone can now control a vehicle safely and comfortably. Francis Davis's power steering technology represented the first successful solution to automotive accessibility, replacing primitive manual steering systems that had excluded millions of potential drivers due to physical limitations. The innovation would transform not just driving comfort, but enable automotive independence for women, elderly drivers, and people with physical disabilities who had been unable to operate conventional vehicles. The engineering achievement was revolutionary. Davis had created a hydraulic assistance system that could amplify human steering input while maintaining precise control and road feel, solving mechanical challenges that had seemed insurmountable with manual steering alone. Most significantly, power steering would prove to be one of automotive engineering's most democratizing breakthroughs, enabling safe vehicle operation for people regardless of physical strength, while establishing the foundation for universal automotive accessibility. If you love discovering the untold stories behind automotive history's most incredible innovations, please like this video and subscribe to the Car Chronicles. 1885–1945. The physical torture of manual steering. For the first 60 years of automotive history, driving required physical strength that excluded millions of potential drivers from vehicle operation. Early automobiles used direct mechanical linkages between steering wheels and front wheels, creating enormous physical demands that made driving genuinely exhausting and often dangerous. Manual steering systems required tremendous arm and shoulder strength, particularly when parking or maneuvering at low speeds when tire resistance was highest. Drivers needed construction worker-level upper body strength to turn steering wheels that could require 50-plus pounds of force for routine maneuvers. Driving was physical labor that excluded anyone without exceptional upper body strength, recalled automotive engineer Walter Chrysler. Women, elderly men, and anyone with physical limitations simply couldn't generate the force necessary to control vehicles safely. We were building transportation that half the population couldn't use. The problem was particularly acute with larger, heavier vehicles that required even more steering effort. Luxury cars and commercial vehicles were essentially impossible for smaller or older drivers to operate safely, limiting these vehicles to young, strong men who could wrestle with steering systems during normal driving. Parking was a nightmare that often required multiple drivers or assistance from bystanders. The low-speed maneuvering necessary for parallel parking could exhaust even strong drivers, while making parking impossible for anyone lacking exceptional physical strength. Long-distance driving was limited by steering fatigue that made extended trips dangerous and exhausting. Drivers would arrive at destinations with aching arms and shoulders, having fought steering systems for hours to maintain vehicle control. Women were particularly excluded from automotive operation by manual steering limitations. Social conventions of the early 20th century already restricted women's independence, and manual steering systems created additional physical barriers that made automotive transportation practically impossible for most women. Commercial applications were severely limited by steering demands that required drivers with exceptional physical capabilities. Delivery trucks and buses needed operators who could handle steering systems that were even more demanding than passenger car applications. Emergency situations became deadly when steering required so much physical effort that drivers couldn't respond quickly to avoid accidents. The steering systems that were supposed to provide vehicle control often prevented drivers from controlling their vehicles when split-second responses were necessary. By 1945, automotive engineers recognized that manual steering was becoming a fundamental limitation on automotive market expansion and social utility. Future automotive growth required steering systems that normal people could operate safely. 1925–1945. Davis's engineering quest. Francis Davis began developing power steering technology in 1925 while working for Pierce Arrow, recognizing that hydraulic assistance could solve steering effort problems that mechanical systems couldn't address effectively. His initial motivation was improving driver comfort, but he gradually understood that power steering was essential for automotive accessibility. Working with limited resources during the Great Depression, Davis developed prototype hydraulic steering systems using principles from aircraft and industrial hydraulic applications. However, automotive applications required different solutions due to cost constraints and the need for reliable operation across vehicle lifetimes. The challenge facing Davis was enormous. Create a hydraulic assistance system that could amplify steering input without compromising vehicle control or creating dangerous steering behavior during system failures. The system had to work reliably in all weather conditions while remaining affordable for mass production. Davis's breakthrough insight was that automotive power steering needed variable assistance that provided maximum help during parking and low-speed maneuvering while reducing assistance at highway speeds to maintain road, feel, and control precision. Davis understood that power steering couldn't just make steering easier, it had to make steering better, explained hydraulic engineer Robert Janeway. The system needed to enhance driver control rather than replacing driver control, providing assistance that adapted to driving conditions automatically. The hydraulic engineering required for automotive power steering was sophisticated and demanded innovations in pump design, valve control, and fluid management that pushed automotive suppliers into new technical areas. Davis developed systems that could operate reliably while maintaining precise control characteristics. Testing power steering required extensive development across driving conditions and vehicle types that exceeded anything previously attempted in automotive engineering. The system had to provide appropriate assistance for city driving, highway operation, and emergency maneuvers without creating dangerous steering characteristics. Manufacturing feasibility was critical to power steering's success. Davis needed production methods that could manufacture hydraulic steering systems cost-effectively while maintaining the quality control necessary for safety-critical automotive applications. Integration with existing vehicle designs required careful engineering to ensure that power steering enhanced rather than compromised vehicle handling characteristics. The system had to work effectively with conventional suspension and steering geometry while providing consistent performance. June 15, 1951. The Chrysler Imperial Revolution. Chrysler introduced Davis's power steering system as standard equipment on the 1951 Imperial, making it the first production vehicle to offer hydraulic steering assistance as fundamental rather than optional equipment. The demonstration for automotive journalists and the public was immediately convincing. Test drivers who had struggled with conventional steering could operate the Imperial effortlessly, while the system maintained precise control and road feel that preserved driver connection with vehicle behavior. The difference was remarkable and immediate, recalled automotive journalist Tom McCahill. The Imperial could be steered with fingertip effort while maintaining the control precision that drivers needed for safe operation. Power steering didn't make driving easier, it made driving possible for everyone. The system's operation was sophisticated but transparent to drivers. Under normal driving conditions, power steering provided seamless assistance that amplified driver input without creating artificial or disconnected steering feel. Only when drivers needed extra assistance did the system's benefits become obvious. Chrysler positioned power steering as fundamental automotive advancement rather than luxury convenience, understanding that hydraulic steering assistance would eventually become essential equipment for all vehicles as automotive markets expanded to include drivers with diverse physical capabilities. Customer response was overwhelmingly positive among drivers who had previously struggled with manual steering systems. Women, elderly drivers, and people with physical limitations could suddenly operate vehicles safely and comfortably, dramatically expanding their independence and mobility. The automotive press recognized power steering as a genuine breakthrough that would influence vehicle design and market development for decades. Technical publications predicted that hydraulic steering assistance would become standard equipment once costs decreased and reliability was proven. However, many manufacturers initially dismissed power steering as expensive complexity that addressed problems most drivers could handle with existing steering systems, underestimating the technology's importance for automotive market expansion. 1952–1965. Universal recognition and adoption. The success of Chrysler's power steering system created immediate interest among other automobile manufacturers who recognized that steering assistance was becoming essential for automotive competitiveness and market expansion. General Motors introduced power steering on Cadillac models in 1952, followed by Ford's implementation across luxury vehicle lines. American manufacturers led power steering adoption, while European companies initially resisted the technology as unnecessary complexity. The economic impact was enormous for automotive sales among previously excluded populations. Dealers could finally offer vehicle operation to women, elderly drivers, and people with physical limitations, dramatically expanding potential customer bases and market demographics. Commercial transportation benefits were particularly significant. Delivery truck and bus operators could recruit drivers from much larger labor pools, while existing drivers could operate vehicles safely for longer periods without physical exhaustion from steering effort. Racing applications provided proving grounds for power steering technology under extreme conditions. Racing drivers initially resisted power steering as artificial assistance, but gradually recognized that hydraulic steering allowed more precise control during high-speed competition. Women's automotive market participation increased dramatically as power steering eliminated the physical barriers that had prevented female vehicle ownership and operation. By 1960, women represented significant automotive purchasing power that had been inaccessible without steering assistance. International adoption followed American success, with European and Japanese manufacturers recognizing power steering as essential equipment for automotive competitiveness in global markets. However, adoption patterns varied based on vehicle size and market preferences. Technical improvements throughout the late 1950s and early 1960s enhanced power steering performance while reducing costs through improved manufacturing processes. Better hydraulic systems provided more precise assistance while improving reliability and reducing maintenance requirements. By 1965, power steering was standard equipment on most American vehicles and optional equipment on smaller cars, establishing the technology as fundamental automotive equipment rather than luxury accessory. 1966. Present, electronic evolution and universal standard. The development of electronic power steering in the 1980s and 1990s provided even more sophisticated assistance that could adapt to driving conditions while improving fuel economy through reduced hydraulic loads on engines. Electric power steering systems eliminated hydraulic pumps and fluid requirements while providing programmable assistance characteristics that could be optimized for specific vehicle applications and driving preferences. Electronic systems also enabled integration with other vehicle stability and control systems. Advanced driver assistance integration created power steering systems that could provide steering input during emergency maneuvers or autonomous operation. Modern electronic power steering supports lane-keeping assistance, automatic parking, and collision avoidance systems that require computer-controlled steering input. Variable ratio steering developed throughout the 2000s provided different steering ratios at different speeds, optimizing steering response for both parking maneuvers and highway stability. These systems enhanced the accessibility and safety benefits that Davis's original hydraulic systems had provided. Contemporary power steering includes features that Davis couldn't have imagined: computer control, adaptive assistance, and integration with vehicle dynamic systems that optimize steering feel and response for specific driving conditions and driver preferences. Fuel economy considerations continue driving power steering development toward more efficient systems that provide assistance without compromising vehicle efficiency. Electric and hybrid vehicles require steering systems that minimize energy consumption while maintaining performance characteristics. Modern accessibility applications include steering systems specifically designed for drivers with physical disabilities, providing customizable assistance levels that enable vehicle operation for people with diverse physical capabilities and limitations. Universal adoption is now complete worldwide, with power steering considered essential automotive equipment rather than optional convenience. The technology that Davis developed to improve comfort has become fundamental infrastructure for automotive accessibility. Modern impact and recognition. Francis Davis's development of automotive power steering represents one of the most important accessibility innovations in transportation history, enabling vehicle operation for millions of people who had been excluded from automotive transportation by physical limitations. The technology's social impact was enormous. By eliminating physical barriers to vehicle operation, power steering enabled transportation independence for women, elderly drivers, and people with disabilities, contributing to social mobility and economic opportunity that had been limited by transportation access. From an engineering perspective, power steering established important precedents for automotive systems that enhance human capabilities rather than replacing human control. The technology demonstrated how engineering could solve accessibility problems while improving performance for all users. The economic benefits extended far beyond automotive manufacturing. By enabling vehicle operation for previously excluded populations, power steering supported economic development and social participation that had been limited by transportation barriers. Market expansion enabled by power steering was directly responsible for automotive industry growth throughout the second half of the 20th century. Manufacturers could finally address market segments that had been inaccessible due to physical operational requirements. Gender equality in transportation was significantly advanced by power steering technology that eliminated one of the major barriers preventing women from automotive independence. The technology contributed to broader social changes in women's roles and economic participation. The accessibility revolution that began with Davis's 1951 innovation continues today as power steering technology evolves to support new automotive technologies while maintaining the fundamental accessibility and control enhancement that enables universal automotive operation. The story of power steering development reminds us that the most important automotive innovations are often those that expand access and opportunity, and that engineering solutions can eliminate barriers that seemed insurmountable with previous technology. From a contemporary perspective, power steering represents a fundamental example of inclusive design that benefits all users while specifically enabling participation for people who had been excluded by previous technology limitations. The hydraulic assistance that modern drivers take for granted represents one of automotive engineering's most successful accessibility achievements, proving that technology can create more inclusive transportation that serves diverse human needs and capabilities. If this story moved you, subscribe to the Car Chronicles and hit that like button. Share it with someone who needs to know that the greatest automotive innovations are often those that make driving accessible to everyone, and that American engineering has repeatedly created technologies that democratize transportation and expand human opportunity. What's your most memorable power steering experience? Let us know in the comments how power steering technology has influenced your driving confidence and accessibility, especially if you remember the difference between manual and power-assisted steering systems.